All right, we are recording. All right, everyone. Hello and welcome back to my Lego Mindstorms walkthroughs. So, in the last video, we went through the action block tabs and we discussed all of these in pretty much as much detail as needed. And now we're going to the flow control tab. So, let's just start off with the first block here. It's the start block. It's the exact same thing as the start block that you get whenever you open a new program. But say you accidentally deleted them. Oops, I deleted it. And now you can put down another start block. You can also just have two programs at the same time in one program tab. So say you want to go move tank in one and then move steering in the other and then compare the difference. You can click play on both of them and then see how they compare with each other or anything like that. So that's basically the basics of the start block. It's just there if you need it. So let's keep it there. And then the next block is the wait block. All right. So this block basically just pauses your program until one condition is true. Whatever condition you want that to be is you can choose that condition. So out of the box, it comes with the time indicator wait setting. So here it will wait for 1 second. So I can change that to say I want to wait for 10 seconds. I can hit 10 and then hit enter. So this basically means it will wait for this for 10 seconds to pass and then it will move on to the next block. So if I had a move tank in front of it and if I had a move tank behind it, it will do this. It will go forward for one rotation, then it will wait for 10 seconds, then it will go on to this. But time isn't the only thing that you can set here. You can also set all of your sensors and even messaging if you have the Bluetooth messaging and the NXT sound sensor. Even though it's an EV3 model, NXT is the one before, you can still use it with EV3. So say I wanted to wait for, let's say, I want to wait for the touch sensor to be pressed. So I will go forward. Let's see. Let's put a move steering and just set it to on. I will move forward indefinitely. Actually no. Let's see. Rotation. It'll move forward one rotation, and then it will wait for it to be pressed. And then once it's pressed, it'll go to the next one. If it's not pressed, then it'll just wait here forever. And yeah, basically this will tailor towards whatever you need. If you have other moving pieces in your project, this is pretty useful. But if you're the only moving thing, then that might be a little hard to use the sensors. So say you have some sort of moving, like a moving arm that you have to catch or something like that. You could wait for the arm to hit your sensor and then it will move on to the next block. So that's basically the wait block explained. We will revisit that in a second. Next, we have the loop block. This is one of the most important blocks in the entire programming software. This is basically where you get to use all of your sensors and actually create logic and use them towards your program. So say I wanted to just move forward until the touch sensor is pressed or the ultrasonic sensor reaches some value. We can choose that right here in this end condition. So right now it's going for unlimited, which means it will just go forever and never stop. So if we click on the unlimited, we can see all of these different sensors and different settings that you can change to set the exit condition. So say I will go to the ultrasonic sensor and then measure distance in centimeters. So now we get compare types and thresholds. So for the compare type, right now it's set to less than. So it will keep going through this loop until it reads a ultrasonic sensor reading less than this value. So say I want it to go until it's 10 centimeters away from a wall or something like that. It will go through this loop until the ultrasonic sensor has reached this, and then it will go on to the next block outside of the loop. So say I have that and then I have it on and then it'll go backwards. Let's say -50 right there. So now it'll go forward and then it'll go back. This is a very basic program, not really going to do much, but it's just an example. You can also set this for any of your other sensors, such as your motor rotation and then touch sensor and gyros. So you can tailor this to whatever you need, and it's there for you. So here, the same thing here, if you go to your gyro sensor, here you can do some turns. So say I wanted to turn at a rate of 10, Let's change this to 10. A rate of 10 at the speed of 50. And then as soon as, let's say greater than or equal to, as soon as the gyro sensor reads a value that's greater than or equal to 10 degrees, then it will exit the loop. So it will basically turn for 10 degrees and then it will leave the loop. This is a pretty basic loop here, but not the best if you want to do some longer programming inside. So say if I had say I have a rotation on, we'll get into that later. Yeah. So let's go to the switch. Switch is the next block. Oops. There we go. And then switch. So this is basically where your robot can make decisions. This is pretty important for your sensors. Again, it can choose if a value is true or if a value is false. And it can, if you put this in a loop, it will happen indefinitely. So here is our actual condition that we're checking if it's true or false. We can change that to whatever sensor or whatever logic that we want. So say we want to go back to the ultrasonic sensor and then compare distance. So here, it will check if the ultrasonic sensor reads a value that's less than 50 centimeters, because we have it in centimeters. We can also have that in inches if we want, right here. So if this condition is true, then it will do this. And if this condition is false, then it will do this. That's denoted by the X and then the check. So say I want to go forward, or actually go backwards, negative 50. Say I want it to go backwards once it reaches a distance of 50 centimeters because, oh, that's a little too close and I don't want to hit the wall. Then it will do that. And if it's not, then you can continue going forward. So I can just leave this on. And there we go. So now this will basically balance itself out between 50 centimeters. However, because this isn't in a loop, it will only check once. So it will check, I don't have anything connected right now. It will check for this once, it will see that it's not, and then it will go on, move forward, and then just nothing else because there's nothing after it. If I want it to check forever or continuously, I can put this guy in a loop that we talked about before, and now it will continuously check, and then say I want it to stop, let's see, 1 second. Count maybe. Say I want it to stop after 5 times of checking. There we go. So once the loop has gone through 5 times, then it will leave. It's a pretty simple exit condition. You can have other conditions too, just like we talked about earlier. But yeah, that's basically the simple switch walkthrough. All right, next we have the loop interrupt. This is the last block in the flow controls tab, and it's actually very powerful. To demonstrate this, I have already created a program right here. It's a pretty basic program. So what it will do is, hold on, let me disconnect this for a second. So this is what you see when you build the program for the first time. So there we go. So we have our start, and then we have a loop. In the loop, we go forward for 1 rotation, then we turn right for 1 rotation, then we turn left for 1 rotation, and then check for the touch sensor if it's pressed or not. That's what this button, this condition means. So it will, once it checks for this to be pressed, if it's not pressed, then it will continue going through the loop, but if it is, then it will leave. However, this condition is not checked constantly. It's only checked after everything inside has been done once. So it goes through this, then this, then this, then checks, and then it goes back to this, and then checks. However, if we want it to check while it's doing things inside of the loop, so say I want to check even if it's going forward, I want it to check for the touch sensor to be pressed. Or while it's turning right, I want it to check if the touch sensor is pressed. Or if it's going left, I want it to check if the touch sensor is pressed. That is where the loop interrupt comes in. So if you click this little tab right here, it shows you the threading. And you can actually drag this thread down to here. So let's get rid of this for now and drag it down to this loop interrupt block. So now what this will do is it will, if I leave it like this, it will immediately leave the loop without doing anything. So that's not really helpful. We want it to wait and see wait for the touch sensor to be pressed. So this is an excellent example of the wait block. So we put down a wait block right in front of it, and instead of time indicator, we go down to the touch sensor and then compare and then state. So now this will wait for the touch sensor to be pressed and then go onto this block. The thing about this is, because it's parallel to the loop above it, it will actually be continuously checking for this. If we just put this right behind here, let's say I unthread this and connect it right over to here, this will never actually check because it's never in the thread, because computers always go left to right. So to make it go check constantly, we have to parallelize this. Let's see. Select this, drag it on over to here, and then it's parallel. If I actually connect it, there we go. Now it's parallel. But what if we have multiple loops in our program? So say I put down another loop. The number up top represents the name of the loop. So this one is 01. This one is also 01, but I can change that to 02 if I wanted. And there we go. And then to change which loop the loop interrupt is communicating with, you can just click here and it will change which loop it is. So if I wanted to interrupt loop 2, I can just click on that and it will leave loop 2, or I can have it on loop 1 and it will leave loop 1. So, yep, that's basically it for the flow controls. Thank you for watching.